In this video we're going to do a couple antiderivatives, both involving u-substitution. And so let's look at the first one here. Now we can't split this up to top and bottom, and it looks kind of complex right now. What I do notice is I have e to the 2x on bottom and e to the 2x on top, and derivative of an exponential always has itself in it. So I might be able to let u be one of these and have my du be in there. So I don't want to pick the top, I would rather pick the bottom because I have this plus 2 also down there that I'd like to get rid of. So I'm going to let u equal that denominator, e to the 2x plus 2, and then my du, by chain rule, is e to the 2x times the derivative of the exponent, so don't forget your chain rule, times 2 dx. I am really close to having that in there. Now this part's just my u, it's already gone. Well, what I might do is I might go ahead and say, okay, well I'm going to pull the 3 out of my integral, and what I need it to be is I need it to be a 2, because I want to match this. So if I put a 2 on the inside, I can compensate for that by multiplying by 1/2 on the outside. So I haven't changed the original integral at all. Now I can do my substitution because the bottom part is just u, so this is 3/2. The denominator is just u, because that's what I let it be. And my du is exactly now equal to the numerator. Now we've had this one before, although it doesn't quite look like it. This is 3/2 ln of the absolute value of u plus c, and the last step is to substitute back. 3/2 times the natural log of our u was e to the 2x plus 2. This is always going to be positive, so you don't need absolute value. If you want to use parentheses, that's fine. Plus c. So what looked complex at first is actually just not too bad of a u-sub. It's what to look for to recognize when you have a u-sub. Let's take a look at one more for a little bit more practice. So I have the ln of x cubed over x dx. Again, I'm going to have a u-sub, and I see that because of the ln of x cubed on top and the x on bottom. Can't split up an integral over multiplication or division. Next thing I notice is I got to figure out what my choice of u is. Well, I know the derivative of ln of x is 1 over x. Let me rewrite this so it may look a little more obvious. I could rewrite this as ln of x cubed times 1 over x dx. The derivative of ln of x is right here, so that tells me it's a u-sub with u being ln of x, because my du then is 1 over x dx. So I can now sub in. This is exactly u because that's why I set it up. So I have the antiderivative of u cubed, and here is exactly right here, so that's exactly my du. So I can now take the antiderivative of a very simple power function. It's just u to the 4th over 4 plus c, or subbing back in the ln of x, I have ln of x to the 4th over 4 plus c. So again, it's about recognizing what your u is going to be. That's the trick in u substitution that you got to get the hang of.